Welcome to another episode of the Listening to the Wind interview series from the International Windship Association. And I'm very pleased to be sitting here today with Roberto Prever from NAOS Design. Roberto, welcome to Listening to the Wind.
Thank you to us.
And I'm really looking forward to seeing your presentation in a moment. But before we get to that, I'll just give a quick introduction of Roberto. So Roberto Prever has an MSc in Naval Architecture and is the founder of NAOS.
NAOS, you can read like
that. Starting as responsible for CAD hull form design and stability calculation, structural analysis, and computational fluid dynamics. Has a strong passion for sail, which I would expect, and is also the designer of several sailing boats. Mostly known for the design of Ro-Ro and Ro-Pax vessels, NAOS has successfully completed dozens of new projects. Partner of NAOS in Sweden and NAOS in Barcelona, managing a staff of about 35 people, including the affiliate company Animos in Croatia. Animos, okay, in Croatia. So without further ado, Roberto, and I think we're in very safe hands here, I'll put over control for your presentation and I'll see you on the other side.
Okay. Thank you, Gavin. I think I would start by sharing the screen and having the short presentation. Share. Is it okay?
Yeah, perfect.
Good. Okay. The presentation starts with a short video, which has already been presented on some. No, that is wrong. Sorry. Here is the video.
We must take care of our planet and reduce waste and pollution as much as possible. The wind is a clean and natural resource. Let's use it again for our ships with modern technologies. Today, it can be done. Work together for a better, clean and efficient sea transport world.
Good. Could you hear the audio of the video?
Yes, that was perfect.
Very good. Let me try to go to the next slide. Okay. Okay. So what we are working on since several years, because indeed we started in 2014. It's which appeared to be quite a long time. It's a wing structure, a modular structure, which could be installed in one or several units on board of the widest range of ship types, without interfering as much as possible with the other operation of the ship. So the solution we found from the beginning is to have a kind of very slender shape with high aspect ratio, and which will be foldable, so to not have any interference with the cargo. We thought initially that for Ro-Ro vessel, with those sail placed on the ship side. And starting from that time, we did a lot of CFD calculation, mostly focused on the single blade study, which of course is not is not exactly what you will have at the end in a real configuration. Then we went through a big number of design iteration, and one of those round led to the installation of a small prototype, which is on board of a ship. We will see later. Now here, this is a slide which shows the pattern of flow and speed on the four-blade located in 4 different positions on a Ro-Ro vessel, which, by the way, it is an existing Ro-Ro vessel where it will be most probably those wing sail will be most probably installed in a few years. I think in a couple of years from now. So we have done quite an extensive amount of work on the aerodynamic optimization and study, and to understand all the implications, which are also on the underwater part of the ship, of course, because you have some drift forces, and you have to cope with that. That effect should not, let's say, impair the normal operation of that kind of ships. We took in mind that the crew of merchant ships, they are not sailing teams, or like in the America's Cup, of course, and they need to have a very simple and reliable system, which should be based mostly on a button that say, I want to use sail or I don't want to use sail. Of course, the automation system should also teach or say this to the master, and with kind of artificial intelligence and decide when it is the case to use or not to use the system. This is the small prototype, which is a 12 meters high blade, which has been installed on board of a Ropax ferry, which is presently in service in Spain, and the ship is operated by Grandi Navi Veloci. That is a prototype which reflects the stage of the design we had almost 1.5 years ago. So now we have done quite a number of improvement on everything, from the mechanic to the blade shape to the construction technology. But nevertheless, this prototype has the function to detect a potential problem and make a set of measurement on a real environment, which is the sea environment, with all related problems, which are ship motions, environment issues, salinity, whatever, storms, things like that. That is again a view from the bow of the ship on the top level helicopter landing area, where you see in that installation, which is a prototype, the folding down is made transversally just for other purpose, for practicity in that installation, but normally it will be along the ship. What we can see here is the measurement of the truss, where the tower where the sail is installed is equipped with strain gauges, which measure the thrust forces. And then we have instrument to measure wind speed and direction, of course, and GPS positioning system. All is delivering information to a box which record everything and transmit to the land everything every time the ship is in a port by the GSM network. So here we see in yellow is the forecast or prediction of the thrust made by the computer, and in blue is the measured thrust. And in that particular case, we see that generally the thrust is a little bit above the expectation in that case, which means a number of things, including that this single configuration in a very good positioning, let's say, takes some advantage from a kind of acceleration of the flow, which happens in the lower part of, in the lower layer of the top part of the ship. So that was quite interesting to see, and then we understood this phenomenon. We modeled it again in CFD calculation, and yeah, now we are also that was, I think, the last, yeah, it was the last slide of that. And we, in this type of CFD model, we are now working a lot on the interaction between the hull, the superstructure, and the cargo, and the sail themselves. Yeah.
Oh, yeah, Roberto, that's very, very interesting. Thank you. If we could go back to the picture before, if that's possible. Yes, so this one. As you say, the blue line showing the actual forces there, the actual thrust being delivered.
Yes.
That must be very encouraging.
That's really
very encouraging to see the predictions being pretty much about 90% of the time you're above your prediction level. So.
Yes, and also the trend is very close. Of course, every kind of measurement you do in the real world has oscillation. You never have a perfect curve as you might think at the beginning, but the trend is quite good.
And how much time has this been in operation now?
That has been in operation since May.
So you've been getting quite an extensive amount of data there. 6 months, 7 months, yeah, fantastic. One thing that I always note about your design, the WSM design, it's, as you say, it's a very thin design. It's much thinner than a lot of the other systems that I've seen, and has a little bit reminiscent of a wind turbine blade. What could you explain why, just a little bit more, why you've selected that thinner blade profile?
Yeah, I think that what you are referring to, more thick profile, is in some cases, I don't know everything, but in some cases are wings which have a suction option, which is a low pressure created by a fan, or that is a different system, and this allows to have a thicker profile, which is good for structural reasons. But on the other side, you have a slightly more complicated system with additional mechanical, a fan, something that made it a little bit more complicated. Now, in the latest profile we are understudy, we have a thicker profile, this one, which is good, and but still is a passive system. There are no active machines or fans, and so yeah, we want to keep it very simple and very cheap to be built, and yeah, to be bought as well, because you know that at the end of the day, the owners, we know many owners, and 10 years ago, if you had presented a system like that, the owner has made a very simple calculation how much fuel they would save and in how long time they will recover the expenditure. Now it's, of course, a little bit different, because we are going to different taxation of the emissions. There are a lot of factors that help us as wind propulsion producer. But anyway, the economic should work.
Indeed, I think, yeah, very much that bottom line. But as you say, there's wind propulsion isn't just driven by the wind; it's driven by cost. It's driven by regulation and other things coming down the pipeline. I have one other question for you relating to the system. What size of installation are you thinking will be maybe the next step after this one? And also, is there any maximum height on one of these, or a maximum size that you're thinking, where a bigger system doesn't have kind of returns, so a sort of maximum returns type shape or height?
Yeah, presently we are doing the complete constructive design for a 46-meter tall system, which is presently where we are focused on. We know that we have the request for a smaller system as well, which could be in the range of the 24 to 30 meters tall. For now, we do not have figure to create higher blades at the moment, but that could happen, of course. Yeah, of course, it's mostly structural challenging, even because this prototype, the blade is made by fiberglass with the same technology of the windmill blades, more or less exactly the same technology. But we want to avoid to use any non-recyclable material, because fiberglass is not recyclable, or it is in a very little extension, or with a high level of degradation of what you do with that recycled material. So we want to use only metallic material.
Right. Right, and I think I think we're seeing moves now within the wind turbine industry around that recyclability. So maybe that will impact onto wind propulsion in the coming years as well. So maybe there will be a few more options out there. But I think that's that life cycle analysis and circularity is really important. Yeah.
And even not only of course that is very important, but also the repair capability for people who are not so skilled. I mean, in many cases, it is easier to make some repair work with metallic material than with fiberglass or composite material, at least in the shipbuilding environment and the ship repair environment. So, yeah, that of course is a challenge, because it is much easier to work with fiberglass, and the product is probably or for sure lighter, which is good. But we going through several calculations, stability, everything. So we think we are sure that we can manage to work with metallic material.
Yeah, no, absolutely, and I think you made a couple of points there. That one about the construction, obviously operations is a very important concern with the blades being retractable. But you also mentioned about the crew and having a turnkey kind of solution for them. That they aren't sailors, and especially on the vessels maybe that you're looking at, they're not going to be highly trained sailing crews. So that sort of simplicity of operation and probably simplicity of maintenance is a really key issue.
Yeah, indeed. Already that installation is made in a way that you have on the bridge, you have a simple panel which can monitor what happens on the sail, but do not require any manual operation. So you just have to say yes, I want to use or not. But once you, like a fin stabilizer for a ship, the master doesn't operate the fin stabilizer. They just say I want to use it or not.
Right.
And all the electronics does all the rest. Of course, in every moment, the master can decide to not use, to fall down. And of course, there are emergency procedure. If something goes wrong, there is some failure of some components. There are two levels of safety before. Yeah, so you can even do a kind of manual operation to put down the wing if necessary.
Yeah. No, absolutely. I mean, I think that risk, that issue of stability is obviously a chief concern for not just for the ship owners, but going through class, going through operations as well. So I'd like to move into a sort of broader discussion a little bit in the areas of the market. So as you rightly saying, cost. Even in these days where regulation, emissions, environment are very important, it still comes down to, are these cost effective, and when am I going to get my return on investment? Which of the market segments do you see as being the sort of primary market for your design, and also wind propulsion in general?
You mean market segment in terms of ship type?
Yeah, ship type. Yeah, so ro-ros, tankers, container vessels, etc.
Of course, for historical reason of our company, we are focused on ro-ro vessel mostly, but also ro-pax vessel, maybe with a smaller level of installation. But yes, originally that was thought for ro-ro and ro-pax. But yeah, on the existing ships, both ro-ro and ro-pax, presently you can't install a huge amount of sail area because the hull simply is not done for that purpose. So you can install a certain amount of sail area, which is the case of our system, of other similar systems. Of course, that is not well conceived for other types of ships. I mean, if you want to have a 40% or 50% of propulsion through the wind, you need much more area. And so a conventional ro-ro vessel or conventional ro-pax vessel cannot be equipped with such amount of without making other addition or other modification. So
right. So potentially for new builds, there's a potential there, but you've got to redesign that. You've got to configure that more to optimize wind as the
we are also working in other direction, but that is for the moment is secret.
Okay, well, I won't push you on that too much, but maybe you can come back and share that when that's not so secret.
Yes.
Fantastic. And we're seeing a lot of change in the marketplace at the moment. We've got a lot of regulatory changes coming through. The EEDI is already being adapted with the new circular for wind. We have EEXI, CII coming through. And on the financial side, the inclusion of vessels into the EU ETS, for example, with carbon levies. And I know that actually the ro-ro and ro-pax sector is very large in Europe in comparison to other sectors and in comparison to the international sector. So I'm just wondering how you see those the inclusion in the ETS and these other regulatory factors. How do you see that influencing the uptake of wind propulsion going forward?
The question is if the market is considering wind propulsion to improve their environment impact measured with the present tools that IMO has implemented?
Yes.
Yes, I think it is. It's not yet, to me today, is not yet it's not a solid knowledge at the moment. The owner itself or the operational company, they have rather vague idea on all this. So indeed, part of our work is also working in that direction to make it clear to some of our customers what they can achieve by even very realistically, because if someone asks as a route in some area of the Mediterranean where the average energy of the wind is extremely low, I will not try to promote anything, because
for sure,
at the end of the day, they will have invested money and just have maintenance costs, which is not a good advertising anyway.
Yeah, no, absolutely. And with the inclusion of the EU ETS, I mean, most ro-ros, I would expect, are going from Europe to Europe. So it's EU to EU. So it'll be 100%. Obviously, we have ro-ros and ro-packs going to the UK and going to Africa, etc. But a lot of this is inter EU travel. So 100% on the EU ETS, and yeah, that could be adding a couple of $100 to the cost of a ton of fuel. Do you see that as being a driver or a substantial driver?
Again, that depends on the economic balance of the investment, because of course operating a ship which is a pure mechanical ship is well known, well established, and let's say easy for any operator. Everything you add on is some complication to be added. So again, if the investment and maintenance cost to keep this wind system in function is comparable to the extra cost of a cleaner or a cleaner fuel, or a fuel plus the taxation, that will work. And there is also a kind of psychological issues that some of the owners, they want to show that they are going to be green and to be clean. So that has a positive effect on that. And
certainly, I mean, I think
it's very visible, you know.
Absolutely, and I think even 2 or 3 years ago, that was probably a negative. That it was a very visible change and seen as being rather strange in the industry. I think now it's, as you rightly say, it's become a kind of, a badge of environmental concern. So I've certainly seen that in other sectors as well. So that's excellent. And I've just got one more sort of general discussion point. Of course, we're in the middle. Well, I say the middle. Hopefully, we're nearing the end of the pandemic, the COVID aspect. And I just wondered, from a company perspective or an innovator's perspective, and also from the industry, obviously, ro-packs may have been affected by this. What impacts have you seen from the pandemic over the last couple of years on your business or your area of development, and also the markets that you're looking at?
Yeah, it's absolutely not easy to be understood. The pandemic has made an increase of work for us. So the general worldwide trade is increased. As you know, the cost to transport a container is rocket high nowadays. And I don't know exactly, I'm not really an expert, I'm a poor naval architect. For some reason, this has brought everything to higher level. there are a lot of order or a good number of order of new buildings. There are a number of investment in green technology. So we never had such a big amount of requests like in the last 2 years, which is strange.
Well, yeah, but good. But that's a positive side of the pandemic. But I'm sure, you know, there are frustrations as there have been with many of our members, you know, parts being delayed that are being delivered from other parts of the world, you know, schedules, countries going into lockdown, and key personnel being sick at inconvenient times. So
also for this small prototype project, we had the whole program was 24-month project, and I think we had more or less 6 months of delay for many reasons. That was exactly across some lockdowns, so the transport of parts was impossible. That has had an influence on the project. But on the other side, the combination of this green technology increase or demand, and maybe the time to reflect on what to do in the future, that now is positive.
I think that's a really interesting point. I mean, perspective. I remember in the first lockdown, you know, which I still can't believe is nearly 2 years ago. But I think that there was a general feeling that, you know, perhaps you know, we can close an economy down to make us all safe, and we can make huge changes, and that gives me hope a little bit for the changes we need to do for the climate change as well. So yeah, so hopefully there's a balance there. There's some good and some bad there. Now, what I'm going to do now is just do a quick fire Q&A for you. So if you could keep your answers to these questions very, very short, 1 sentence.
Yes or no?
Yeah. Maybe not yes or no, just a little bit more than that, but a very quick fire. This is a sort of 5-minute thing. First of all, how did you get, one, how did you become a naval architect? 2, why did you embrace wind propulsion?
Oh, I tried to build for myself a 2 meters long boat with sail when I was, I think, 12.
Great.
And from that, I did all the rest. I don't know if you can see on top of my head, there is a sailing catamaran, which I did.
Can just see that, yes. Yeah.
For myself 20 years ago. Then I did a number of other sailing boats. So to me, sail is very important.
Well, yeah, that's fantastic. And you know, there's a lot of sailors in your part of the world as well. So some beautiful boat designs. Yeah. Now, you know, coming through, if you like, if you could go back and talk to that 12-year-old self who was building that 2 meter vessel, what advice would you give them? Would you give your 12-year-old self?
Difficult question.
I said I wouldn't ask you a difficult one, but I've asked you.
Always look and with an understanding approach to what you see around. You have to look, and through the deep looking to what is existing, you have to understand exactly how it works. And that is the beauty of this. The physics of sailing, navigation by wind is very interesting physics.
So observation is absolutely key. Yeah. Okay, great. And what is the with this project, what is the most difficult issue that you and your team have kind of encountered? So obviously COVID has been a challenge, but you know, during the design process or the even the installation of the rig, what was the most difficult issue?
I think is building technology, construction technology. So in order to keep it as simple as possible and to keep down the level of cost of production, that is a big challenge. Because we think that our system will be out in the market it should be in a couple of years. Now we are doing the 44 or 46 meters high blade. And I think we should be in a segment, for my understanding, which is half or 1/3 of the concurrent prices.
Yeah.
Because of the simplicity, not because we deliver material which are not good, but I mean, just because of the simplicity.
Well, I guess you're maintaining quality, but simplifying that's the challenge, yeah. And keeping the costs down, but maintaining the robustness of the system, yeah. And what is the most common misconception about your rig? When somebody sees the rig, they go, that they have some misthought, or they don't know what it is.
Depends who is looking to that. We heard people say, why it doesn't turn? Because one of the most popular devices, of course, today is the flattener rotor system. So they expect to see it rotating, or the windmills there in the common knowledge of people. So they expect some movement, and then don't see any movement. This is small adjustment of the blade. That for now.
Well, maybe that's a nice misconception, that it's a passive system that people almost they don't see it because it's not moving. So very interesting.
Like an airplane wing, when you fly, you don't do any movement.
Yeah, no flapping. Yeah. And okay, I'm going to ask you a couple more questions. What is the most frequently asked question that you get about wind propulsion or about your system?
Again, depends on who is posing the question. From seafarer or masters, they are concerned about ship stability and the effect in a restricted area, restricted waters, like the entrance of ports and so on. But that is easily solved by saying that the automation presently on that system, when detected that the ship is slowing down because it's into a port, automatically puts down the sail anyway.
Right.
So that is mostly our question related to stability or windage. And
the one question that I ask everyone on the interviews, but I think you've already answered it to a degree, is around life cycle analysis, around recyclability, and I think you've given that a lot of thought. So I don't think I need to ask that question, because that one's fine. But the final question, I know quite a few people that will be watching this video will have this question, is you're heading to market with a larger system. That's a lot of work. So are you recruiting at the moment? Are you expanding your team? Are you looking for opening offices or a small fabrication factory in the future?
Presently, since almost 2 years, we have hired 2 mechanical engineering. One is aerodynamic guys. He spent all this professional in aerodynamic in several fields, including automotive and aircraft. And he's working 8 hours per day only on that project. And then we have another mechanical engineer. He's working again full-time for mechanical design and optimization. And then, of course, we involve other people of the staff time to time for different parts. But yeah, we are those two guys.
Oh, okay, fantastic. So send your CV if you're interested in working in the area.
Yes.
Okay, that's great.
We have to hire people, but it's very difficult to find people today.
Well, let's hope that changes. Let's hope that changes. So Roberto, yeah, thank you very much for joining the interview. I'm going to give you the last say though. So you've got a minute or two, a summary or a takeaway that you'd like to give the audience. I'll hand it over to you.
Yeah. What can I say? I hope that through this amount of work we will be successful in a couple of years to see some of the cargo or ro-ro ship we have designed or we do not have designed, because we are cooperating also with other design office, to have some full-scale installation with happy and satisfied owner, which can say at the end of the day, we have saved 10% of our fuel bill, and the ship is easy to maneuver. There are no issues for crew, and that will be already, let's say, kind of a good target to achieve. Fantastic.
Well, I'm pretty much convinced you will get there and get there fairly quickly. So, wishing you all the luck on that. And that just leaves me to round up the interview. So you've been listening to the Wind from International Windship Association, in conversation with Roberto Prever from NAOS Ship Design, and I'm sure that Roberto will be happy to answer any questions if you'd like to send those to him about his system or anything that he's talked about today. And of course, on the wider wind propulsion field, IWSA is always happy to field questions and send additional information. So thank you very much, Roberto, for your time today.
Thank you.
And wishing you all the best with everything. And we'll have you on next year with a big update on the project and how things are going.
Very good. Thank you. Thanks.
Fantastic. Thank
Bye.
you very much.
Thank you.